The last two inequalities that we want to practice involve absolute value. Let's do a quick review of absolute value. When we're looking at the absolute value of x, we know that this equals x if x is greater than or equal to 0, but it equals the opposite of x if x is less than 0. This is known as a piecewise defined function because it has two pieces. So what that means is if we're asking for the absolute value of 3, we see that 3 is greater than 0. So it's just going to equal 3. If we're looking at the absolute value of -3, well, now I see that -3 is less than 0. So I need the negative of x. In this case, x is -3. The negative of -3 is, of course, +3. The absolute value of 3 equals 3. The absolute value of -3 equals 3. The answer to absolute value questions are always positive. Whatever is inside those absolute value signs becomes its greatest distance from 0, a positive distance. But what this means when we're solving for inequalities is that what's inside could be positive or negative. So we have here the absolute value of 2x minus 3 is less than or equal to 1. What's inside the absolute value sign could be positive or negative. This means whenever we're solving an absolute value inequality, we have two inequalities. One with the positive value, one with the negative value. Why don't you go ahead and see if you can solve each of those inequalities. For the second inequality, we can open the brackets or we can multiply both sides by -1. I'm going to open the brackets, but it doesn't matter. Subtract 3 from both sides. And remember, when we're dividing by -2, the sign changes direction. So I've got two numbers that I need to put on my number line, 2 and 1. Remember that smaller numbers are always on the left. We see that x is less than or equal to 2. So 2 gets a closed bracket, less than 2, greater than or equal to 1. My interval notation uses these endpoints in the order they appear. Both of them have a closed or square bracket. And I can see from the number line that x is the values between and including 1 and 2. So when we write our set notation, all the values of x, such that 1 is less than or equal to x, which is less than or equal to 2. Why don't you pause your video and try question 4. So again, we have the same two numbers we want to put on our number line, but the shading's a little bit different this time. X is greater than 2, so we're shading towards positive infinity and using an open bracket. X is less than 1, So we're shading towards negative infinity and an open bracket. This time for interval notation, we have two intervals. The first one uses the endpoints negative infinity and 1. Both have a round bracket. The second interval uses the endpoints 2 and infinity. And again, both have an open or round bracket. We say that our solution is the union of each of these sets. In set notation, we would have to write two inequalities for all values of x such that x is greater than 2 and x is less than 1.